In Lecture 9, we'll look at systems development, and this will comprise of two main areas. So these are policies relating to building and maintaining secure software. This is section 14 of the ISO framework. So it's information systems acquisition, development, and maintenance. And the focus is going to be here on security requirements of a system, application and code, whether or not you're developing the code in-house or you're outsourcing that, or it's been commercially developed. We need to know something around how software is going to be acquired, developed, and maintained within the organization. And also there is an element of cryptography. And here is the focus is going to be on the proper and effective use of cryptography, which is closely related to systems development and maintenance. So in this lecture, we'll be discussing systems acquisition development and maintenance. These policies relate to the building and maintaining of secure softwares. So this involves two domains. Firstly, information systems acquisition and development and maintenance, and cryptography. So systems acquisition primarily focuses on the security requirements of a system application and code, whether or not that's developed in-house or outsourced or commercially developed. And then secondly, cryptography focuses on the proper and effective use of cryptography, which is closely related to systems development and maintenance. So we've been having, there's been quite a lot of serious security problems in software for many years. Much of today's software still has vulnerabilities, and part of the reason for that is that people the product life cycle is very short. There is constant updates, constant threats, and a lot of these things result in poor code. So the need to cut costs will often lead to developers and managers cutting corners. And building secure software requires more time, and that's a precious commodity in business. Sometimes people just don't know better, and oftentimes security is considered a secondary function to the actual software working. And so, part of the reason for that is that it's sort of bolted on after the fact, as opposed to built in to the development. So oftentimes the primary functionality is to focus on the software design and testing. So what is the primary function of this design? And it stands to reason, actually. That you'd want more emphasis on that because that's what's valuable. But the problem is that if you have insecure software, then it can result in a breach or vulnerability exploit. You have to impress upon the people that you're working with that there are risks to an organization running insecure software. So if vulnerabilities exist, it could be exploited in denial of service attacks or SQL injection attacks, so leading to classified data leaks. And this can result in loss of productivity, loss of trust, and bad public relations. So how can organizations encourage the development and maintenance of more secure software? So you need policies for that. So the System Development Lifecycle Policy provides a structured and standardized process for all phases of system development. And the System Implementation and Update Policy will define the requirements for the implementation and maintenance of commercial off-the-shelf and open source software. So that's, you need an implementation and update policy for that. An application development policy will define code and application development security requirements. This is how we'll know, what are the security requirements for a given application. The software development lifecycle has 5 phases. First, there is the initiation phase. So here the need is going to be expressed and the purpose is documented. This is very important. So it has to be a very clear understanding of what the aim is. And then there is the development and acquisition or acquisition. So this is system design, purchase, programming, and development. That can take a long time, depending on the size of the organization. And then, you'll have a group of people, usually consultants or the vendor, engaged in system testing, modification, or retesting, and acceptance. And then there's going to be the ongoing operational maintenance of the system. So once it's put into production, there may be still errors or vulnerabilities and maybe new features. Sometimes, you don't want to buy the whole software. You just buy a component of it. And, you add as you go along different modules, let's say. And as you do that, you will need ongoing monitoring, testing, and auditing of the system. Then finally, once the software goes out of use, you have to terminate the system. You've got to safeguard vital information. You've got to migrate that data to a new system. That's a big job, right? So whenever you have to migrate to a different system or you're terminating that system, there's a lot of work to do for the disposal to ensure that the data is protected. A software development lifecycle policy is an absolute must if the company is developing software. And this will encourage a culture that stresses and values the importance of secure and clean code. So if you're in a company that's developing software, this policy is going to be particularly relevant. As with all policies, it's important to assign responsibility to a system owner at this point, and then the development team leads or IT head. Assigning responsibility is a key task of SDLC policy, and you can include items that are related to design and as well as third-party evaluations as part of that policy. So how do you create this culture of clean and secure code? Well, you have to hold every developer responsible for creating clean and secure code and trying to tying that to your work objectives. So as part of the job description, for example, or the performance review, you want to make sure that there is, the objectives are somehow related to the creation of secure code. And then you have to be having reviews on every developer's code. Now you can't make exceptions here, because if you do, and then there'll be a lot of pressure to make exceptions because of crunch and time constraints. But when you do that, it's very likely that mistakes will be made. So code review is a process that aims to catch errors in the code prior to release. The reviewers may or may not belong to the organization. They're unlikely to have worked on the project, but they can be experts in relevant fields that understand the code, and again, they're normally not involved in the project because they're too close. Otherwise, they'd be too close to it. So code review often catches many errors. It's not perfect by humans after all, right? And so it's the case that reviewers may not catch everything. An application's development policy has to exist within the company within the company developing the software, and it's going to assign responsibility for the oversight of secure development to the system owner or the project lead. This might refer to standards and practices relating to writing secure code and testing. So that's what you'll find in your applications development policy. Some things you want to consider when developing consider for secure development. You've got to think about the input validation, so ensuring that there's a correct format and no characters. When there's expecting numbers, you've got to make sure that the data is plausible. That is to say, the exchange rate of information from third-party source is within a certain range, making sure that that's valid. And then there's the output validation, and that's ensuring that there's no data leaks, especially in error cases, as error message can provide some hints. If there are lots of error messages, you can it's likely highly probable that there is some data leakage at some point in your development of the code. Other things you want to consider for secure development is how to manage sensitive data. You want to perform a risk assessment to determine the relevant threats to sensitive data, then implement a solution to protect the data while stored and in transit, and you've got to protect against modification, loss, and misuse. Then lastly, you will test the solutions under all known or possible threat cases. So it's quite a lengthy, time-intensive process. Another part of secure development is setting code standards. So coding standards specify the subset of a programming language that should be used agreed upon structure for writing code. So a set of coding standards can be referenced within the policy, and you would want a standard that is separate for the policy in this case, because there may be new vulnerabilities, and you're trying to you can refer to the standard for that purpose. So new vulnerabilities and types are discovered over time, and the standards are being updated frequently as a result of that. So rather than changing the policy, you can just incorporate the standard by reference, and then you would know that you're using the latest version of the standard. So that's how you're going to reference to some established coding standard. Systems implementation and update policy deals with issues relating to the use of commercial and open source software. This includes items relating to stable software releases, updates, testing, and test data. It considers the underlying operating system stability. It'll assign responsibility for designing patch management processes. And then the testing environment. You want to make sure that the testing environment is separate from the production environment and using simulated data. Because if something goes wrong with the test, you want to make sure that it doesn't affect your production line. System stability refers to entire production system, including the operating system, and that needs to be tested for stability. Only these tested versions should be deployed on production servers, and any change or update could affect stability. So typical reasons to update software: a security vulnerability has been discovered, and the new code eliminates the issue, or a non-security threat, a non-security related bug is found, and the new code resolves those issues. So those are the reasons you want to update your software. A patch management policy ensures patches are applied in a manner that considers their potential effect on stability. So example items can be, for example, updates should be tested in a lab environment and declared safe prior to release on production servers. The updates should be applied during a time that will affect productivity the least, so early hours in the morning. Critical security updates may be applied immediately, and then it'll also specify, your patch management policy will also specify who will apply the updates. That is to say, a member of the IT department, for example. Rollback policy has its objective to bring a server or an application to the stable state in which it was prior to patch deployment. This may involve backup software particular to the system. It may involve creating or archiving full system images, but you should consider the time needed to perform a rollback if that's required, because that can take some time. Cryptography is pretty key here. You have cryptographic tools that are used in secure software, and that deals with sensitive data. That's why we talk about it, and that's why we're talking about it today. Cryptography is a vital, important aspect of security of the security of data and information assets in general. As we know, the efficacy of cryptography depends on the security of the key used. So policies here needs to address threats to the keys. So either not being secured by users or software, weak keys created by poor pseudo-random number generators or poor user-chosen secrets. Policies must also highlight and specify best practices for the crypto systems in use. Key management policy assigns responsibility for key management and cryptographic standards. So example items can be all sensitive data must be transferred in an encrypted format. All data that needs integrity must have digital signature. You may wish to reference a standard to specify which algorithms and implementation standards should be used. Then who is responsible for protecting encryption keys for the entire organization. And then describe when a digital certificate will be used and who is in charge of revoking that certificate. So those are sort of aspects to a key management policy. So I'll leave it there. If you have questions, we'll take them up in class, and I look forward to seeing you in class. Take care.